what is big data and why Hadoop. In the last previous session, I was just briefing you. Hadoop is for batch applications. Hadoop is not for online applications. Means user interactive applications, we call it as online. Batch user non-interactive applications, right? Batch applications. Drawbacks of current databases. Limited storage, no parallel processing, volume increases, speed decreases. If complexity increases, speed decreases, right? Yes. Databases can handle up only structured data. Hadoop doesn't follow client server. Hadoop follows master slave architecture, right? And a group of nodes connected in a network. Cluster is what? Group of nodes connected in a network. There are two types of nodes: master node, slave node. Master responsibility, task assignment, load balancing, fault tolerance, and health monitoring. Slave node responsibilities, storing data and processing data. Hadoop advantages: unlimited data storage, very high speed processing, can handle all varieties of data, open source, right? No licensing required. So processing point of view, Yahoo has taken a table of size 100 TB consisting of 1024 columns. Oracle, right? It has taken nearly 3.5 days to process this. Means performing this task. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netezza has taken 3 hours. Hadoop has taken 3.4 minutes. Latest of Hadoop has taken 1.2 minutes. Why databases like Oracle cannot perform unlimited storage means there is a limit for databases. They can go up to this many slaves, right? 256. For specialized databases like Teradata and Netezza, they can go with 1024 slaves. But still, we cannot say it as unlimited or huge data storage. Right. There is no limit on the number of slaves that Hadoop can have. When first time Yahoo implemented Hadoop, it went with 4,000 slaves. Currently, it is going with 12,000 slaves. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, going with 42. Hadoop ecosystem components. HDFS, MapReduce, Apache, Pig, Hive, Scoop, Flume, Kafka, and Spark, right? Yes. Now today, how exactly data stored and processed, right? How exactly data stored and processed within Hadoop? How exactly data stored and processed? In Hadoop, data is stored in the form of data is stored, right? Data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided into blocks. Data is stored in the form of files. Each file is again subdivided into blocks. Default block size. Each file is again subdivided into blocks. Default block size. Latest version. In latest versions, default block size is default block size is 128 MB. Default block size is 64. In latest versions, default block size is 128 MB. Okay, if we talk about this, right? If I got a file f1.txt, right? If I got a file f1.txt, size. There, 192 MB, assume. f1.txt size is 200 MB. MB, right? Yes. Default block size. (64 MB). Number of blocks, how many? Number of blocks. File size by default block size. (64) by default block size is what? Sorry, 200 by default block size 64. (200 by 64). How many blocks? 4 blocks. B1, B2, B3, B4. B1, B2, B3. B1 64 MB, B2 64, B3 64, and this B4 just only 8 MB, right? Yes. (56 MB is free here. 56 MB is free. Assume this data is okay. F1.txt data is some banking data. Now f2.txt, right? I'll just say f2.txt. Size 192 MB. Exactly 3 blocks. B4, B5, B6. B4 64, B5 64, B6 also 64. Why this B4 data here? Block 1, block 2, block 3. Slave 1, slave 2, slave 3. Slave 4. So these are stored in slave 4, slave 5, slave 6. S4, S5, S6. Now here, why B4 data? Here 56 MB is free. Why B4 data not stored in this? For example, I want to retrieve f1.txt. I want to retrieve the f1.txt data. Retrieving f1.txt means which blocks I need to access? B1, B2, B3, B4, right? Yes. B1 plus B2 plus B3 plus B4. If file to stored in f1.txt, f1.txt, right? Yes. If file to stored in f1.txt, B1 is what? 64 plus f1, f2, f3.txt is what? So this slave 1, slave 2, slave 3, three different slaves processing three different tasks, right? If B4 data stored in B3, sixty-four plus 8 plus 56 MB. Actual file size is 200. But you are getting 256 MB, 256 MB. 56, whenever I am retrieving customer.txt, if I'm a banking data, if I, so you are getting some bank offers. So this thing that it is telecom data. B1, B2, B3, B4, right? 64, 64, 8 plus 56. Actually, this is wrong computation, right? Wrong computation because actual file size is 200 MB, but here it is 256 MB. So 56 MB of 56 MB, right? You got 56 MB of other data into this, right? Yes. So design principles with respect to HDFS, right? So design principles based on this, right? Design principles with respect to HDFS. Design principles with respect to HDFS blocks. Every file will have dedicated number of blocks. Within a single block. Within a single block, no files, no two files data to be stored. All the blocks will have equal value. All the blocks will have equal value. All the blocks will have equal volumes except the last blocks. Okay. So design principles with respect to HT, every file will have dedicated number of blocks. Within a single block, no two files data to be stored. All the blocks will have equal volume except the last block. Okay, now I'm going to discuss some cases, right? I will be discussing 3 cases to understand what happened internally, how this data and storage is going to happen, right? If I take a file, 1 second. If I take a file f1.txt, file1.txt, 192 MB. Number of blocks, how many? 192 by 64, 3 blocks. B1 here, B2 here, and B3 here. So 193 blocks means B1, B2, B3. B1 by slave 1, B2 by slave 2, B3 by slave 3. Yes. In slave 1, B1 is stored. In slave 2, B2 is stored. In slave 3, B3 is stored. Slave 1, slave 2, slave 2. Think that 3 blocks consisting of 30 lakh records. Okay. 192 by 64, 3 blocks. How these 3 blocks B1, B2, B3 stored in slave 1, slave 2, slave 3. And this is name node, master node, right? Maintains the metadata. Maintains the metadata. F1 dot file 1 dot txt. F1 dot txt divided into blocks B1, B2, and B3, where B1 stored by slave 1, B2 by slave 2, B3 by slave 3. Yes. B1 by slave 1, B2 by slave 2, B3 by slave 3. How exactly data is divided into blocks? The blocks are distributed across the slaves. Right. Master node stores the metadata information. Right. Now, how data processing happens? Data processing. Your job is to process f1.txt into how many tasks? Number of tasks equal to number of unique blocks. I'm saying the word unique blocks. Number of tasks always depends on number of unique blocks. How many unique blocks here? 3 blocks, right? Three tasks, right? 3 tasks. 3 tasks means 1, 2, 3. Slave 1, slave 2. Sorry. Data processing, right? Yes. 3 tasks, T1, T2, and T3, right? T1, T2, and T3. Job is to process f1.txt. Who should execute this T1 task? Now try to answer. Slave 1 only, right? There is no other choice. Because T1 is for executing B1. For executing B1. So for who should execute T2 task? Slave 2. Who should execute T3 task? Slave 3. So here, 3 different slaves are executing 3 different blocks parallelly, right? 3 different are executing 3 different tasks. Full parallelism, you see. You see like full parallelism. Very high speed, right? Yes. Okay. Slave 1, slave 2, slave 3, executing T1, T2, and T3. Yes, all the 3 slaves, right? all the three slaves S1, S2, S3 are executing three tasks T1, T2, T3 parallelly. Okay, so this is how data stored and data processed within this Hadoop, right? So one more example. Any queries in this, anyone, before I go with the other? Case 2. Okay, now observe this case 2, right? Case 1 is what? Number of blocks greater than number of slaves. Number of blocks. File 1.txt. Size 192 MB. One 92 by 64. 3 blocks total. How these blocks are stored means this is master, these are slaves. Slave 1, slave 2, slave 3. Within the slave 1, B1, B2, number of first case 1 is number of blocks equal to class number of blocks greater than number of slaves. Assume only two slaves, but 4 blocks. B1, B2, B3, B4. Observe here, right? 192 by 64, you will see like okay, don't say 192, 212. 212 means 4 blocks. B1, B2, B3, B4. Here metadata information f1.txt divided into B1, B2, B3, B4. These 4 blocks S1, S2, S1, S2. This is what how data is stored, right? And data processing. Job is to process f1.txt. Yes. Job is always defined into number of tasks. Number of tasks equal to number of unique blocks. Number of unique blocks. How many blocks? 4 blocks. 4 blocks, 4 tasks. Job is to process f1.txt, right, into 4 T1, T2, T3, and T4. T1 task for executing B1, T2 task for executing B2, T3 for B3, T4 for B4, block 4. In Hadoop, data is stored in the form of blocks, files, and blocks, right? And this T1 task, who should execute? Slave 1. B1 bar is present in slave 1, so T1 task executed by slave 1. This one by slave 2, this one by slave 1, this one by slave 2. B2, okay, B2 is present in slave 2. Again, B3 is present in slave 1, B4 in slave 2. Means slave 1 executes 2 tasks, T1 and T3. Slave 2 executes 2 tasks, T2 and T4. When T1 is executing, when T1 task is executing, right? T3 will be in the waiting state. When T2 is executing, T4 will be in the waiting state. Means at a point of time, T1 and T2 only executing, remaining are in the waiting state. Because here, less parallelism, less speed. Okay, less speed, right? If more blocks, less number of slaves. But see that case 3, right? Observe this case 3. More blocks, only one slave. More blocks, only one slave. More blocks. Think here 3 blocks, only one slave. It's fine. So this is f1.txt. The size is like 192 MB. How many blocks? Number of blocks equal to 192 by 64, like 3 blocks. How these 3 blocks are stored across this master and slave? Single master and only one slave, right? Only one slave. All B1 here itself, B2 here itself, B3 here itself. All the 3, okay. f1.txt divided into 3 blocks, B1, B2, and B3. B1 stored in slave 1 only, B2 also in slave 1, B3 also in slave 1, right? All the 3 blocks stored in the slave 1 only. Means here, processing, if we talk about job of f1.txt into how many blocks? Number of tasks, number of unique blocks. How many blocks? Number of tasks equal number of unique blocks. How many blocks? Three. 3 blocks means 3 tasks. T1, T2, and T3. So my job is to process f1.txt divided into 3 tasks, T1, T2, and T3. T1 executed by slave 1 only, T2 by slave 2 only, T3 by slave 1 only, slave 1 only. All the tasks are executed, all the tasks. All the tasks are executed by single slave sequentially. Sequentially, right? Yes. So here in three cases, right? If more slaves, more speed. Only less slaves, less speed. Only one slave, no parallel processing, right? Yes. But here I got one query, right? If you go back to this case one, within this case one, here, this is your master, these are your slaves. S1, S2, and S3. Here B1, B2, B3. So assume if three tasks, T1 task, T2 task, T3 task. If three tasks are executed by the three slaves, three tasks are executed by the three slaves. Suddenly, if this slave goes down, B2 data is lost, T2 task is failed. How Hadoop is able to overcome this kind of situation means we have got concept called replication and fault tolerance, right? What is replication? What is fault tolerance? I'll be briefing you about those things in tomorrow's session. Replication and fault tolerance in Hadoop. Hadoop has got a powerful fault tolerant model. So that's for that and Hadoop architecture I'll be discussing, right? Yes. So tomorrow the link is going to be changed. So everyone need to get enrolled, right? You want to continue in this, right? So software will be provided, clear notes. Every day you are getting the video of it. Yes. Any queries you have got, anyone? Okay. So I said more concentration will be on Spark with Scala. Next, Hadoop components all will be discussed line. HDFS, MapReduce, Hive, Scoop, NoSQL, HBase, streaming components, right? So I'll stop for now. We'll continue tomorrow, but tomorrow you should get enrolled, right? Fine. I'm stopping. Continue tomorrow.